Yes, class, good morning. Today we'll discuss here a new topic, method of solving first order, first degree differential equations. Means how to solve first order, first degree differential equations. Means how to find out the solutions of the first order, first degree differential equations. In last exercise, you have learned what given equation is the solution of the differential equation or not. Solution is given, but you will check and verification in the last exercise. And 9.2 you have learned it, this given equation is solution of differential equation or not. But in this exercise you will be learn here what is the solutions of the given differential equation. Solution is not given, you will find the solutions of the given differential equations. Now look here, suppose given dy over dx equal to, suppose any equation is given here. Suppose this is the first order first degree differential equation given here. So how to solve these equations here? Means this is the two function here, two variables here, x and y. Yeah, any other two variables here. So then how to solve this first order first degree differential equation? So then first of all you will doing separate here. This you will doing separate here h, y and gx. First of all you will be separate of the variables here. Those function having the x variable, then doing separate. Those values those function having the y variables, then doing separate. Then the dy over dx, then the dy over, you will be hy here and gx dx. Then you will be separating here this dx and dy. Those function having the those values having the y values, y variables, then separating left side with dy and dx separating the gx. After then you will be integrating both sides. Then what will you come here? Dy over hy equal to gx dx. After that you condition how to find the solution of these conditions. Then we will be integrating both sides in every equations. Then suppose solution of this here is hy. Suppose here the solution of this part here hy. Then our solution here this part here gx plus c. So this is the final solution of the given differential equation which having the first order first degree, the solution of this differential equation. How to find you? With help of the integrating. With help of the integrating you will find the solution of the given differential equations. And every equation you will solve according this way. Yes, note down it, then we will start the exercise. Yes class, we will start the exercise 9.4. Find the general solution of the given differential equations. You have know what is the general solutions, what is the particular solutions. The general solution, those solutions having the arbitrary constants, this is called the general solutions. Or what is the particular solution, those solutions not having the arbitrary constants called the particular solutions. In this question you will find your general solution. Here equation you look this question equal dy over dx 1 minus cos x upon 1 plus cos x. Here not variable, only single variable. This is the first order and first degree. This is the first order and first degree differential equations. First order and first degree differential equations. You will find the general solution of these equations. Yes. Now start the solution here. First of all, you will be separating the variable. But here only single variable xx. Here is not required the transposing here because here only single variable x. Then you will transposing here only dx here. And now the dy equal 1 minus cos x upon 1 plus cos x into dx. After that you will be using your integrating both sides, integrating both sides. Then integration of dy over integration 1 minus cos x upon 1 plus cos x dx. So this portion having already separated. But 1 minus cos x, 1 plus cos x, you will using the trigonometric identity here. What trigonometric identity here? 1 minus cos x, you can write here 2 sin square x by 2, and 1 plus cos x, you can write 2 cos square x by 2. In place of 1 minus cos x, you will write here 2 sin square x by 2, and 1 plus cos x, you will write here 2 cos square x by 2. How it possible? Now 1 minus cos 2x, cos x, not 2x, cos x. 1 here, same here, but you will write the identity of cos 2x, then removing the 1 here, this identity here 1 minus 2 sin square x by 2, 1 minus minus plus 2 sin square x by 2, this one removing, so 2 sin square x by 2. Means with value of the 1 minus cos x, 2 sin square x by 2, I am directing right here 1 minus cos equal to 2 sin square x by 2. Same thing here, similarly here 1 plus cos 2x, so then you can write here 2 cos square x by 2. Then 1 minus cos 2x means 2 sin square x by 2 upon 2 cos square x by 2 dx. Using these identity here, these two identity here. So then 2 will be cancelled here. What is left? Tan square x by 2 dx. Means this portion will be cancelled here 2. So what is left here? Sin square upon cos square, then tan square. After then you have no any identity of the direct integrate of the tan square. You have no any direct identity of the, you can integrate of this function. So then you will break down this sec square x by 2 minus 1 dx. You know 1 plus tan square x equal to sec square x. According to this identity, here sec square and 1 transforming this side, and here x by 2, then theta, here theta place here x by 2, so then you write here theta plus x by 2 here, so means tan square x by 2 equal sec square x by 2 minus 1. You can write this way. After that you will integrate here. What will be your integration? Tan integration of this portion to y equal, what will be of this? This is the y. Y equal integration of this sec square means tan x by 2. Integration of the tan sec square x by 2 means tan x by 2. And what is the integration of the x by 2? Is 1 by 2 means 2 or minus x and plus c. Or integration of the 1 here, so this x, or integration of sec square x by 2, tan x by 2 into 2, or this is the constant c. Y equal to tan x by 2 minus x plus c. This is your general solution of the given differential equations. This is the general solution. Why general solution? Because you are putting c. C is the arbitrary constant here. Then the name of this solution is called the general solutions. And this solution is the solution of this given differential equation. So in this differential equation, the general solution is y equal to 2 tan x by 2 minus x plus c. According this way, you will solve every question. First of all, will be separating the variables, then you integrate, and then you will find the answer. This is the helping identity of the integrations, trigonometry. Yes, student, next question I am taking question number 4. This is a very important question and different type question of this exercise. Question number 4 here, same thing, find the general solutions of this differential equation. This one is the differential equation, but you are not looking at differential, but you are differential equations. Sec square x tan y dx. This is a dx here means differential equation. Sec square tan x in dy means this is symbols of the differential equation equal to 0. So first of all you will separating this equation, then you will be integrate and then you will find the general solutions of the given equations. Yes, now so then you write here is sec square x tan y dx plus sec square y tan x dy equal to 0. So you will separating here to sec square y tan x dy equal minus sec square x tan y and dx. Means this portion you are transposing this right side. Sec square x tan y dx you are transposing the right side, and this portion is the left side. After that you will separating the variables here. Here dy means dy those trigonometric function has the y, then you will transporting the left side. Here sec square y, this is the unlike here, then you taking your tan y and dy equal to minus sec square x, or this the tan x is the unlike here, then you will transposing this here tan x dx. After that you will integrating here, integrating both sides. What result come here? Sec square y upon tan y and dy equal to minus sec square x upon tan x and dx. Now look here, this is the only term of the y here, all variables here y are here, all variables here, all terms here, all function here the term of the having the x. So then you can integrate it, but how it possible to integrate direct here, but it is not possible to direct integrate here because you have no any single identity you can use and integrate it. So how to integrate? So first of all you will be substitute the value here. Suppose you are substituted tan y equal to something t here n and u, then differentiate of tan y equal to sec square y. Same thing here, suppose you are putting the tan x equal to here b, then what value differentiate of tan x? The sec square x. So it means this integration required here the substitution techniques. Now put tan x equal to u, differentiate sec square x du over dx, then what value of the dx equal to du over sec square x. This is the value of the dx. Second things n, tan y equal to b means sec square y equal to dv over dy. When you differentiate of this with respect of the y, differentiate of the this function with respect of the y, the sec square y and dv over dy. This function differentiate of the with respect of the x. So tan x equal to sec square x and dv over x. The same thing you find the value of dy here, so means db upon sec square y. You will put this value in both side here. dy value you are putting here and dx value you are putting here, then you will get the answer. Yes, you note down it, then solve the head. Yes, students, you will putting the value of the tan x and tan y and dx and dy in this condition. Yes, now sec square y upon what value of the tan y is the v, and what value of the dy here, the dv over sec square y minus same thing here, what will sec square x upon here u and multiply here. What will be of the dx here? So du upon sec square x. So this one is cancelled and this one is cancelled. What is left here? db over b equal to minus 1 upon u and du. 1 upon b into dv. So this is your left part. 1 upon b dv minus 1 upon u du. This portion is easy to integrate here. So now integration here, the log b equal to minus log u, and what constant you will take here? Don't take here c. You will take in here log, both side here log, then you take in constant as a log c plus log c. Then you will taking the constant here log c. You taking the c, otherwise log c, both things is same. This means this is the constant value. C or log c, both things are same. You are taking, you will taking the similar pattern log b, log u, then you taking the constant as a log c. After that you will be what value of the log b here? You will substitute the value of log b, means tan y, and minus you are putting here tan x plus log c. After that you will be putting here what value of the b here? Tan y, and value of the here this tan x putting the u, and this tan y putting the b. So you transposing the left side here log tan y plus log tan x equal to log c. According to property of the log, according to taking the property of the log here, we are transporting this side, then log m plus log n. What value of the log? Log tan x into tan y equal to log c, and log both side here, then you eliminate here tan x tan y equal to c. This is your answer. This is your required required general solution of the given differential equation. This is the general solution of the given differential equation of this. This question is a very important and different type question of this. Every question suppose come in this form, so you will be first separating, then integrating. What is the method of the integration here? You will using any tricks here, substitution tricks, by part tricks, and any other tricks, partial fraction tricks. You will take the tricks of this and then integrate it and calculate, and then you get the general solution of the given differential equations. Yes, note down. Then next. Yes, student, next question I am taking question number 9. This is a different type questions. Different type question, you will find the general solution of the given differential equations. dy over dx equal to sin inverse x. So first of all you will doing separate, and then you will find the integrate, and then you will find the general solution. But here only single sin inverse x, or sin inverse, you notice sin inverse x direct, you have no integration of this. So then how to integrate of this? So you will be using your product rules of the integrations. Yes, now start the solution here. dy equal to sin inverse x dx. Then integrating here, integrating both sides. So dy equal to inverse sin inverse x dx. In this step, you have no any identity of the direct sin inverse x integration. So how to integrate of this? So then you will be take your integration of sin inverse x of taking first function, or taking 1 here second function. Sin inverse 1 is sin inverse but you will taking the product rule of the integration. Sin inverse will be sin inverse, but when this you will take the first function and this will take the second function. This will take the first function and this will take the second function. So you will according to Euler rule. So then first function sin inverse x integration of the 1 dx minus integration what d over dx sin inverse x and integration 1 dx and over dx. First function integration of the second function minus differentiation of the first function integration of the second function and over dx. So you will be using your product rule. Suppose sin inverse and cos inverse in separate here and single terms here. The sin inverse here same. So this will be sin inverse x same. Then this x integration of the x 1 is equal to x minus integration sin differentiation of the sin inverse x 1 upon root 1 minus x square. Differentiation of the sin inverse x here 1 upon root 1 minus x square. This is a differentiation, and this one is the x and dx. This dx right here. Again here you can write x sin inverse x. You can write this step here, and you can write here कि x upon root 1 minus x square and dx. How to integrate of this portion again? Suppose you are substitute this value any variable third variable here now 1 minus x square here suppose you are putting here you t, then differentiate here minus 2x dx equal to dt, then you can write here dx equal to minus dt over 2x. You have no any direct identity you can integrate of this portion. So then you will be substitute this value 1 minus x square you are substituting here t, differentiate this the minus 2x dx equal to dt, the dx equal to minus dt over dx. So putting this value here integration of this value is a y. Now y equal x sin inverse x minus what will you come here x upon t and here minus dt over 2x. This x will be cancelled here. What is left? X sin inverse x minus minus here plus and 1 by 2 taking outside, or this t taking to 1 by minus 1 by 2 minus 1 by 2 dt. This 2 taking out minus into minus here plus this 2 taking outside at 1 upon this 1 upon t exponent 1 by 2. You can write here t exponent minus 1 by 2 in the reciprocal of this. So this 1 upon t exponent 1 by 2 you can write here t exponent minus 1 by 2 here. Then easy to integrate of this. So what will be your x sin inverse x plus 1 by 2, or what will you come here? Then will you have plus 1 means 1 by 2 and upon 1 by 2 and plus c. When integration of this, the plus 1, the plus 1 means minus 1 by 2 plus 1, the plus 1 plus root t. Y equal here x sin inverse x plus 1 by 2, and these two transposing this, then 2 here and t exponent, you can write here t root t plus c. X sin inverse x, these 2 will be cancelled here. What is left? Root t, and what value of the t here? 1 minus x square. Then you can write here root 1 minus x square plus substitute the value of this. This is your general solutions. X sin inverse x, what value? Substitute the value of t here. T equal to 1 minus x square, then root 1 minus square plus c. According to this, you will solve the questions. Every question, suppose any inverse function is single here, then you will be multiply by the 1, then you will taking the inverse function or be taking the first function, and multiply by 1 you will taking this second function. Then using their product rules, after that we integrate, or suppose in this type condition then we will substitute here. After substitution you will find the integrate and you calculate and you will get the final general solution of the given differential equation, this differential equation. So this is the general solution of the given differential equations. Y equal to x sin inverse x plus root 1 minus square plus c. So here c is given. Here c is given. So it means this is the general solutions of given differential equations. According this way you will solve every questions. Yes, note down, then next.